In this lesson, we're going to identify the slopes of parallel and perpendicular lines. Example 1, how do I determine the slope of a parallel and perpendicular line? So let's go ahead and take a look at number 1. It says identify the slope in the y-intercept and then graph both of the lines on the same coordinate plane. So we have two equations here, meaning that we have two lines that we're going to be looking at. Our first equation says y is equal to 4 minus 3x. And then our next one is y is equal to negative 3x minus 2. So let's identify the slope. Remember that we have y is equal to mx plus b. And remember that the m is the slope and our b is our y-intercept. And in order to be able to tell the slope and the y-intercept of an equation, you need to have solved and put this in the slope-intercept form. So the two equations that we have are in slope-intercept form. And notice that I have negative 3, or the minus 3 is with our variable. So our slope for our first line is negative 3. And then remember that our y-intercept is a number without the variable, and so my y-intercept here is 4. In our next equation, we have our negative 3 with our variable, so our slope is negative 3. And the number without the variable, you can't forget that minus 2, so that's a negative 2. All right, so let's go ahead and graph these two equations. Remember to graph in slope-intercept form that we are starting on the y-intercept, and the y-intercept here is 4. So I'm going to plot my 4. And then because my slope is negative 3, I'm going to go negative 3 all over 1. So I'm going to go down 3 over 1. 1, 2, 3 over 1. So here's my first line. All right, in our second line, notice we have a y-intercept of negative 2, so we're going to start on the negative 2, and from there I'm going to do my negative 3 slope, which is down 3 and then positive 1. All right, so from the negative 2, we're going to go down 3 over 1. And then let's draw a straight line. So what do you notice about the two lines? Well, notice how they are going in the same direction at the same rate. And so they're never going to touch. And that means that they're going to be parallel lines. So let's go ahead and identify the slope and the y-intercept again, and then we'll graph them. And so notice for our first one that we have it already solved for y, and so our slope is the 1/3, and our y-intercept is the number without the variable, and that's our 3. So for this one, we're going to start on the 3, and we're going up 1 over 3. And so we're going to draw a straight line. All right, for our second equation, notice how it has not been solved for y. So we need to get this y all by itself by minusing the 1 on both sides. We're going to have y is equal to negative 3x minus 1. And so we're going to have a negative 3 for our slope, and we're going to have a negative 1 for our y-intercept. So for this equation, we'll start on the negative 1, make our point, and then we're going to go down 3. Remember, it's rise all over 1. Down 3 over 1. And now for this one, I'm going to draw another straight line. All right, now if you drew them straight, and I don't mind, could have been straighter, you would notice that these two lines have a right angle. And when you have two lines that make a right angle, that means that they are perpendicular from one another. So these two lines are perpendicular. All right, so now let's go ahead and take a look at what do we notice about the slopes of the parallel lines. Well, let's come up top here and take a look at the parallel lines and their slopes. Notice how the slope for the first line is negative 3, and the slope of the other line, or the next line, is also negative 3. So what we know about the slopes of parallel lines is that they have the same slope. All right, and then what do we notice about the slopes in the perpendicular lines? Well, Let's take a look here. Our first one, we have 1/3, and then we have a slope of -3. All right, so what's happening with our slopes for a perpendicular line is that notice how one is positive and then the other one is negative. That's how we get what we call the opposite. So it's the opposite. And so because the first slope was a positive, the second one is negative. And then also notice then how it's the reciprocal. So we've done the flip. Instead of having 1/3, we'd have 3/1. So we made it a -3, and so we call this an opposite reciprocal. Slope. All right, so let's go back and talk a little bit about the diagram that we had, or the graphs that we had on the top. So notice for our first line, we went down 1 and over 3. And our second line, we went down 1 and over 3. And so take note that because they're parallel lines, they have the same slope. They're going in the same direction. And because they're going at the same direction, same rate of change, they're never going to touch. These lines will never touch on the coordinate grid. Now look at our perpendicular lines. And again, notice how there was that square and the right angle there. And so for our first line, we went down 2, so -2, and then we went over 1. And our second line, we went up 1 and over 2. Notice how they're the opposite reciprocals. So because my first slope was a negative, my second one is a positive. And then the flip, or the reciprocal, of -2/1 is 1/2. So we're doing the flip, or the reciprocal. So parallel lines, same slope. Perpendicular lines have the opposite reciprocal slopes. All right, so determine whether each pair of lines is parallel, perpendicular, or neither. Remember, parallel lines are going to have the same slope. And if you found the slope of this first line, you'd know you're going up 2 over 3. And our second line, you're going up 2 and over 3 again. So we know that these are parallel. All right, so let's take a look at the number 2. Notice how we're going down 3 over 2, so our slope for this one is -3/2. And our slope for our second line is we're going up 2 over 3. So let's talk about this. So we've got positive 2/3. Notice how the second line there is negative. So one's positive, one's negative. And then we have the reciprocal. The reciprocal of 2/3 is 3/2. So that makes these perpendicular. And you could, for perpendicular, we could just draw this. That's a symbol for perpendicular. All right, now notice this next one. We do not have the same slope. We do not have perpendicular. We don't have opposite reciprocal slopes. So this is neither. All right, for number 4, let's take a look at our equations. Notice how they are both solved for y. They're in slope-intercept form, so we can identify the slopes. Our slope for our first line is 4. Our slope for our second line is 4. So since they have the same slopes, they're parallel. Our next set of lines, our first line, notice how we have a slope of -5. That one has been solved for y. But here I need to get the y by itself, so I'm going to add the 5x to bring it to the other side. And we'll have y is equal to 5 plus 5x. And so we have a positive 5 for a slope. Now, notice how one's positive, one's negative. However, notice how it has not taken, we have not done the flip. So the perpendicular slope of -5 would be positive, but then we'd have to take the flip of and make that 1 all over 5. And because this one is not the opposite reciprocal and it's not the same slope, this is going to be neither. It's neither parallel or perpendicular. All right, our next one, we have a slope. They've both been solved for y, a slope of 3/5 and a slope of 5 all over 3, negative 5 all over 3. So we have 3/5 is our slope is equal to 3 all over 5 for our first one. Our second one, our slope is equal to negative 5 all over 3. And notice how the first one's positive, the second one is negative. That's the opposite part. And that we've taken the flip or the reciprocal of 3 all over 5. It's 5 all over 3. So these are perpendicular. All right, so now we're going to determine what the parallel or perpendicular slope will be. So notice here we have a slope. It's been solved for y, so we have a slope of 3/4. So our parallel slopes, remember, are the same. So our parallel slope would be 3/4. The perpendicular is going to be the opposite reciprocal. So the opposite of positive is negative. And then, so we're going to have a negative, and then the flip of 3 all over 4, or the reciprocal, is going to be 4 all over 3. All right, for number 2, it looks like we have to solve for y. I'm going to add the 2x. And we have y is equal to 4 plus 2x. All right, so our slope here then is 2. So to have a parallel slope, you're going to have the same slope. Our parallel slope would be 2. And now we have to take the perpendicular. So the opposite of positive is negative. And then remember, if you've got a 2, it's like having 2 all over 1. So to take the flip, or the reciprocal, we're going to go 1 all over 2. So the perpendicular would be negative 1 all over 2. All right, so for the third example, we're going to have to solve for y. So we have to start by minusing the 4x. So we have 2y is equal to 12 minus 4x. And then we're going to have to divide by 2. And remember, when we divide by that, we're doing that hard problem. So we're going to have 6y is equal to 6. And then we're going to have minus 2x. All right, so our slope here is negative 2. All right, the opposite of negative is positive. And so we're going to positive. And then the reciprocal of 2 all over 1 is 1 all over 2. All right, so we need to know the parallel slope and the perpendicular slope. Notice how we don't have the slope here. So we're going to use the slope formula to find the slope. All right, so let's find our slope by taking the y of 2. We're going to minus the y of 1 all over the x of 2 minus the x of 1. So minus negative. All right, so the top number is going to be negative 11. And the bottom number, this becomes a plus. So negative 4, it's going to be 1. So our parallel slope, where it's going to have a slope of just negative 11. So our parallel slope will be negative 11. And the perpendicular slope would be the opposite reciprocal. So the opposite of negative is positive. And then the flip of negative 11 all over 1 is going to give us 1 all over 11. All right, let's do the next one. Again, we have to find the slope. We have to find then the parallel and perpendicular. All right, x1, y1, x2, y2. So 1 minus negative 7 all over 6 minus 5. These become a plus, and so we're going to have 8 all over 1. So our slope here is 8. The parallel slope will be 8. Opposite reciprocal, the opposite of positive is negative, so it's going to be a negative. And then the flip of 8 all over 1 is 1 all over 8. So in this lesson, we took a look at how to find parallel and perpendicular slopes.